This is all wrong. I shouldn't be up here. I should be back in school on the other side of the ocean. Yet you all come to us young people for hope. How dare you? You have stolen my dreams, my childhood with your empty words, and yet I'm one of the lucky ones. People are suffering. People are dying. Entire ecosystems are collapsing. We are in the beginning of a mass extinction, and all you can talk about is money and fairy tales of eternal economic growth. How dare you?
Here, I've got an experiment for you. Safety glasses on. By the end of this century, if emissions keep rising, the average temperature on Earth could go up another 4 to 8 degrees. What I'm saying is the planet's on fire. There are a lot of things we could do to put it out. Are any of them free? No, of course not. Nothing's free, you idiots. Grow the up. You're not children anymore. I didn't mind explaining photosynthesis to you when you were 12. But you're adults now, and this is an actual crisis. Got it? Safety glasses off.
Well, good evening, everyone. I'm Al Vaso, and thanks to the thousands of people who have joined these podcasts live. As the podcasts are really in their infancy, this has only been a few weeks, but we're really overwhelmed with your support, so thank you so much for that. And the usual reminder, in case there's technical issues or we drop the live stream, give us a couple of minutes to get back live and on air. But you can check back anytime at rumble.com/user/IanJuby/live. Once again, that's rumble.com/user/IanJuby, IanJuby/live. Now that link will take you to whatever live stream is running at that time. Now, of course, we have Ian Juby. He's in the house, and joining us in the studio is our in-house mathematician, Alan Montgomery. Alan, I'm sorry, Ian, you have a little bit of a clip you want to play here, is that right?
Oh, yes, that's right.
Yes,
right.
let's throw it in for the viewers.
I'm doing too many things at once here. And I hope everyone will be patient because, like, literally, we had 1 second here. We literally had until 3 hours ago, we had no audio equipment. So we're a little scrambling here for a second. But yes, I want to show this because, just because it's important.
Alan!
You always come through.
Alan!
There's two of us here.
Alan!
Oh, so that's not Alan. Steve, that's Steve. Steve! Oh, no, that's not Steve. That is Alan.
Alan! Did someone just say my name? Hey! You say Alan?
For absolutely no reason whatsoever.
I love it. Well, there's two Allens on our podcast tonight, which is amazing. And let me talk about the other Alan. Alan has an honors degree in mathematics from the University of Victoria. He's been involved in the creation science movement for almost 40 years now. Now, he's been on the board of multiple creation science organizations here in Ontario for over the years. Now, he also worked in the field of actuarial mathematics, which is something I had to look up, which is used in the mortality studies for insurance companies and pension plans. We'll also remind everyone, by the way, that the views expressed in this live stream are those of the participants and not necessarily those of Core Ottawa. So once again, we're going to be going to the chats live tonight on Rumble. So please keep the comments respectful. And if you wish to support this channel and future live streams like this one, Rumble has the YouTube equivalents of Super Chats. They call them Rumble Rants. So where you can give a tip and get your comment or question highlighted. Now, if it's your first time giving a tip, you'll have to fill out the payment plan info, but the larger the tip, the longer your comment stays highlighted and at the top of the chats. Now, for the rest of 2023, and this is probably one of the most exceptional things, is 100% of the tips giving through Rumble Rants goes directly to the creators. Now, Ian, I think you have a little bit of a plug you want to give for a DVD deal, don't you?
Yes, we do actually. I've been financing this for myself. Just so you all know, we appreciate the tips and support. And so there's a couple ways you can support us. Last week, of course, the big topic was UFOs, aliens, after that Whistleblower came out. And we do have some follow-ups, by the way, for those of you joining us again. Last year, maybe it was 2 years ago. That time flies. It was a while ago. Anyway, when the U.S. Senate had their disclosure where they had to report about UFO sightings and all that, and they had, when that came out, I put together this 4-part mini-series, and that's not the slide I'm looking for. Give me 1 second here. There it is. What's it doing down there? Anyway, so I put together a 4-part mini-series, and it was intended to be very exhaustive in terms of dealing with the UFO, aliens, and the Bible and Genesis all at once. And so right now, strictly to support the podcasts, normally you can get that 2-disc set for $40. Currently, right now, it's $30. Go over to ianjuby.org and go to the store. You can also get this in Blu-ray. I forget what price the Blu-ray is going for, but full high-definition Blu-ray. It's a 2-disc set, roughly 2 hours worth of content. So last week, of course, we had Joe Jordan and Guy Malone on. Yeah, I saw him in the podcast last week when I called him D. Only once. Only. I wasn't looking at the screen when he did that. So last week, of course, there was a bit of extra research that had been done since I put together that mini series, the Falcon Lake UFO, for example. But that was fascinating last week. That was a lot of fun.
It really was.
So,
there's a lot of great information that came out of that one.
Yeah. So the mini series, it actually, where did it go here? There it is. The mini series actually goes into a lot more detail. For example, I went into Joe Jordan's story, where he was a New Ager. He was not a Christian, and he went on a flight and got a book at the airport to read on the flight, and it was a book on UFOs. He became obsessed with them, and that's when he joined the Mutual UFO Network, became a researcher, a field researcher, and that's when he started running into what he called experiencers last week. And we got to come back to that, because Joe said a few things last week that I think went over everybody's head, but he ran into experiencers, which are people who believe they've been abducted by aliens. And it's very traumatizing. It basically boils down to kidnapping and rape. It's not pleasant, and it never happens just once. It happens over and over and over again. And so all these people came up to him, and they're like, can you help me? And he's like, what do you do about this? He doesn't know what to do. And so he just did the MUFON thing and took down the report, right? So one day he met a guy by the name of Bill Defendall. And Bill had, adult content warning for a second here, okay? So if you've got kids in the room, cover their ears for a second. I'm going to get graphic. So Bill was an experiencer, and the aliens showed up again one night. Typically it happens at night when you're lying in bed. And in his words, they had him on a pole up his anus, suspended above the bed. And Bill had just recently become a born-again Christian. And so he started crying out to Jesus for help. Just because, you couldn't stop them. This had happened many times before. There was nothing you could do about it. You just endured it. But when he started calling out, Jesus, help me, he said the aliens made a sound like they were hurt, dropped him in the bed, left, and never returned. And so for Joe, this was earth-shattering. He had never heard this before. And so he went back to the other MUFON researchers, and they all secretly admitted to him that they had also heard similar stories, that the name of Jesus Christ would make these aliens leave. And that's when he wound up becoming a born-again Christian, because he saw very quickly it was a spiritual matter, not this wasn't aliens. What's the name of that very famous scientist did the Cosmos series originally?
I know what you're talking about.
I've forgotten his name all of a sudden. But he was completely secular. He's an evolutionist, and even he said it in writing that he's a guy who believes there's aliens out there. He was one of the guys who launched the SETI project, searching for extraterrestrial intelligence. And you can it's on the tip of your tongue too. Right?
He's a cosmologist.
Yes,
right?
that's the one.
Neil deGrasse Tyson?
No, he did the second series.
That's
okay.
going back to the 70s. He had a TV series.
Original. Okay.
Yeah. So anyway, he wrote in writing that it was more likely these aliens were demons than aliens. And he's a secular evolutionist saying this. Anyway,
right.
we're getting off topic. But the one thing I did want to touch on from last week. Let me go to my notes here.
Carl Sagan?
That's the one.
Yes.
Thank you.
Sagan. Yep.
Carl Sagan. That's the one.
Yes. The sage one.
The sage one. Yeah.
That's the one.
So, okay, why is this thing? There we go. Okay, so I showed this map. Let me see. Okay, let me see if I can figure out how to do this now. I believe. Oh, this is the one. Add to stream. Oh, by Jove. Why is it doing it that way? Oh. This is the one. This is the one I want. No, that's not the one I want. Okay, let's remove that. Okay, well, I was going to try and show the screen. But anyway, what about you, Al? Can you see that?
I can see the screen.
Can you see that fairly well?
I see that. I see the whole window with a bunch of slides on the left-hand side.
Okay, cool. Wait a minute. That's not the slide. What's going on here? It broke on me.
But it's showing up on the screen between you both.
Yeah. So okay, let's just do that then. I'll solo it to us. Because I showed these pictures last week. Go away, Lenovo. Goodbye. So you remember this, right? So
yes,
we had a whole pile more follow-up last week on the fires and stuff. One thing I forgot to mention, which is really important. So this first image I showed with all the images up in Northwest Territories, all the fires, sorry, up in Northwest Territories. This was 10 days prior to this one. Now, the reason that's important is because a lot of people were coming back to that satellite image, right? And they were saying, you know, like all these fires started at once. No, actually, these ones, you can see the difference there. So basically, it stayed like this for about 10 days. And what happened was that's when that lightning storm blew through, and overnight it went from this to this. But the main point I wanted to make was, look at all these fires that were already running, that were already burning for 10 days prior to the uptick in the fires, right? Anyway, that was the point I wanted to make. But we'll move on because I know you got to take off there, Al. So YouTube comment for the win after the Falcon Lake. Did you make the Falcon Lake segment? Falcon Lake UFO in Manitoba in the podcast. So
yeah.
Where the guy, you know, offers to help the guys in the UFO. So
True Canadian.
Yep. So it was C. Ritter on YouTube. Comment for the win. That's so Canadian to see a flying saucer land, assume they're in trouble, offer to help, and not think anything of it. It's like, hey, looks like your flux capacitor is out of juice. I'll just go to the pickup and get you some gas, and we'll have you back on the road in no time. Thanks, C. Ritter. That was awesome. You made my day with that comment. So this past week, this guy came out with a 3-hour live stream. The link is in the references. 3-hour live stream with more whistleblowers, literally to the tune of hundreds of whistleblowers, alleging that the shadow organizations, they were pretty specific. It's not so much the U.S. military, although it's probably a branch of, but he's saying these are covert people that are recovering UFOs, recovering alien bodies, etc. And I know Joe and Guy took a quick look at this, but it was more of the same. And so this is the part I wanted to get to because I think most of the viewers last week missed this. So I kind of wanted to cover this because you'll notice when you listen to some of the testimonies here, as Joe alluded to last week, the previous whistleblowers, so Chris Grush, the guy last week, the whistleblower last week that came out, he admitted later on that he had never seen any of these UFOs or alien bodies, alleged. But Joe has already heard from other whistleblowers who have seen these craft. And did you catch this out? So Joe described it. These guys, it's occult. Is what it is. It's a cultic practice. This guy is talking about this craft, and he would go up and touch the craft, and he described it as a conscious entity. So is it a UFO or not? So these are all the whistleblower leaks that are coming out. They're talking about these living entities, which ties in, of course, with the whole Close Encounters of the Fourth Kind research that Joe and Guy do. So the question comes up, just what is it we're looking at here? You've got literally hundreds of whistleblowers now, many of who claim to have seen the actual recovered UFOs. But when you hear the actual descriptions, it's like, hold up here. This is an entity. This isn't a machine. So anyway, I wanted to touch base on that too. I'm going to skip over that because you got to get going, and we're already 20 minutes in. Okay, so we're going to kick it off into the topic of the day, global warming. Do you want to stick around, Al, or do you want to take off, or what do you want to do?
I've got a few minutes. I'd like to hear the at least the next maybe 10 minutes or so before I do have to log off. Okay. Unfortunately.
Cool. So I'm going to. Everyone's going to witness Al clawing his own face off. Statistician Al is just going to love my graph here. So what I've got here, this is based on the whistleblowers of last week and previously, from all these years, from literally going back as far as the 1920s. So what I did was I graphed an accumulated total of whistleblowers, approximately, coming right up to 2020 and beyond, where we're now into the hundreds of alleged whistleblowers and intel leaks of the U.S. Allegedly having extraterrestrial craft that they've recovered and bodies. I also put on there a corresponding line based on the infamous hockey stick graph of global temperature change. So that's in hundreds of a degree Celsius on the scale. And notice the correlation. Strong correlation. What would you say that is in correlation wise? Like,
It's irrelevant because the two events are not connected.
oh, come on.
Oh, yeah.
But there's a correlation, though, right? What would you calculate the correlation to be?
Oh, about 50%.
What? Only 50%?
Yeah.
Oh.
Look at the gap between that and that. That lessens the correlation.
Oh. Well, I still think aliens caused global warming. That was the whole point of it.
Oh, wait a minute. There's an angle we haven't looked at. Maybe global warming caused aliens.
Okay. Granted.
250 and 250 and that opinion will buy you a cup of coffee.
Sorry. This is true. By the way, I don't have monitors. How is Alan coming across there in terms of sound?
Great. His volume could go up a little bit, but I think everything else is perfect.
Okay, I brought it up a little bit.
Oh, okay, good.
And hopefully we don't blast anybody's ears.
As long as you don't make me a loudmouth.
Too late. Okay, so with that, let's talk about this. Everyone talks about climate change. It's always climate change.
Well, they talk about it, but it doesn't mean they make any sense.
Yeah, well, correct.
Right.
But the point I want to start off with is it's global warming. Let's call it what it is.
Mm-hmm.
They want to play the silly semantics game of, it's climate change. So if it snows out, it's climate change, and if it stays the same, it's climate change. If it gets hot, but Bill Nye isn't freezing his globe; he's setting it on fire.
Right. Well, the thing is, if you control the language, you control the issue.
I like that.
That's what's going on. There's no science in that.
Right. That's true.
It's all power. It's all socialism.
Yep. And what we've
or
seen,
worse.
Yeah, and we've seen a lot of that with the pronouns lately and stuff like that as well. So, but yes. So the only point I wanted to bring here was, let's call it what it is. It's global warming, not climate change. That's semantics. It's global warming. That's what they're talking about.
Yeah. Well, if you see a proper graph of temperature, you will see lines going up and down, and they're all very spiky.
Yep.
Right. So,
which I didn't put one on here. I'm sorry.
So when you see the spiky parts, that's the range of temperature that you're recording. Maybe daily, maybe monthly, whatever. Right. So the spiky part is weather. And in this dimension, it's climate.
We just lost.
There I am.
Oh, I don't know what happened there.
Yeah.
There it is. It's back. Okay.
So if you see a line that's relatively flat when they do the average, but it has big spikes, that means you've got widely varying temperature, but not widely varying climate.
Right.
Which is typically non-threatening.
Right. And so playing off of that, I want to ask 4 questions, which we need to address.
Only 4?
Only 4. Well, it's 4. I've narrowed it down to 4. So,
okay. How dare you?
That's coming. That reminds me. Yes, thank you for doing that. Did you hear that, Al?
I hear you now.
No, can you hear? Did you hear Greta?
No, oh yes, at the beginning, yes, I did.
No, right now.
No, I didn't hear that.
Oh, how can we get that going? I soundbited her.
Is it the famous "How dare you"?
Yes.
I didn't hear it, but I knew what you were talking about.
You can't hear it though. Well, if you can't hear it,
No.
that means no one else can hear it. I call it
Probably.
Greta. And every time someone says something controversial, I want to play Greta going, "How dare you?" If it's not going to work, that just makes me sad.
Oh, I see. Oh, how dare us? Oh, I thought you were saying, how dare the United Nations?
Yeah, well, that too.
How dare the United Nations put me, a 15-year-old, on the podium in the middle of all the cameras going around the world and have them read a statement that she knows nothing about. She just knows what's come out of a textbook.
And speaking of which,
How dare the United Nations do that?
yeah, Greta Thunberg, somebody pulled an older video of her, not that old because she doesn't look like she's aged much, where she's in a crowd of people, and this is before she became the poster child of climate change. And I don't know if you've seen it, and there's some words I'm not going to repeat, but there was a chant that broke out in the group, and she was leading it. And in the chant, it was the song, "You can stick the climate crisis up your... You can stick..." Have you seen that?
No. Not sure
It's all over. Yeah, well, it's basically her mocking the climate propagators, I guess. This is prior to her becoming the poster child, where even she did not believe in the climate crisis until they propped her up. But yeah, the video's online. Anybody can see it.
Yeah, I'm starting to get a song coming to my mind. It's from the 60s and 70s. It goes something like, "It started long ago in the Garden of Eden."
There you go.
To Eve. What the heck's driving climate change?
That works. Let's see. Look, I'm going to try this again. I should turn the volume up. You still can't hear that, eh?
No.
I can hear it in the. Okay. Anyway, well, anytime someone says something controversial, I call it the regretta.
The regretta. Well, we can imagine it and just play it in our minds.
I think everyone can hear it except you, because I can hear it in the monitors. But,
oh, strange.
That makes me sad. Okay, so coming back to our fourth question. So it's global warming, not climate change. We already settled that. Is the Earth warming? If it is it our fault? If it is, what can we do about it, if anything? And if it is it a bad thing if the globe is warming up?
Well, the first thing you have to understand about the whole system is that everything in the climate domain is a cycle.
Right.
It goes up and it goes down.
And it goes way up and way down.
So for the last 400 years, it's been going up. Right. So, have we got we've got a slide that gives you all the different cycles that the mathematicians have found, or the astronomers. They've discovered them mostly in the 18th and 19th century.
This one?
No, this one. 30.
That one?
Yeah. Okay.
No, that's the farms.
Oh, it looks like that.
Oh, okay. That one?
Nope.
No?
No. It's a table of names that are cycles. Debris cycle and the Schwab cycle.
I don't think I got that one.
Oh, okay. Well,
this makes us sad.
At any rate, if you list all the cycles, that are in the past, all except 2 of them. There's at least 14 that were on the table. All except 2 of them are, in fact, driven off the sun and the planets.
14 different cycles.
Oh yeah, well you've got the Earth that's wobbling on its axis.
Oh yeah, okay,
right?
okay. I see what you're saying.
And you've got the the sunspots.
Yep.
Now the sunspots go in an 11-year cycle.
Yep.
But the average temperature issued in the sun, every sunspot sequence changes temperature. And that's a 2,300 year cycle.
Right.
And it goes down and it goes up.
Yep.
And you also have a cycle that's called the Bond cycle, and it's 334 years. And you have another one that's about 230 years, and another one that's about 60 years. And these are quite substantial in terms of the change in energy or the forcing.
Yeah.
Right? So it's very important then to take all these cycles and add them all up together. Right? If we got the an illustration of that, I saw it up there earlier.
Hey, my sister just told us, was it Carl Sagan? I didn't see the comment. Yes.
Yeah. So we have a slide there, and it's a bunch of squiggly lines all going up and down at the same time.
This one.
Which one?
That's the aught slide.
No, I'm looking at a line that goes for 1,000 years in the
1,000 years.
Yeah, they add the cycles together, one on top of the other. We had it up. That's how you pick it off here. It's a graph.
I don't think I had it on here.
I saw it up there.
Oh, wait a minute. That one?
Well, no, that's this each temperature graph is a different color, right?
Okay.
And they add up to 1,000-year cycle.
Okay. Maybe this one?
That's the hockey graph.
That's the hockey. Is it? Oh yeah, you're right. It is.
Yes. We'll get around to the hockey graph.
Okay.
It was a very pretty one with many colors.
Oh.
A graph with many colors.
I haven't got a clue what you're talking about. Let me just make this extra large. Now, Al, you got to take off?
I got a couple more minutes. I'm looking as well to see if I can find this graph. In effect, I know what he's referring to. They take the cycles and expand it over 1,000-year span, and you can see the graph would show where everyone is affected by every cycle.
Yeah,
is that correct, Al?
Yes. And
yeah.
What's very important is that if you do a proxy data for the last 1,000 years, and you're looking for astronomical correlations.
Wait a minute.
The activity, there it is.
That one. That was the video clip you sent me. Okay, yes. 1 second. Stop screen. Screen. Two.
There we go.
So the only way we got to hear is here, because that was the video clip you sent me.
Yes.
So.
Yeah. So what you have there are all the different cycles, and it's named on the graph there, and all these temperatures are then added together arithmetically so that you get the total temperature. And then what you do is you look at the proxy of carbon-14, and carbon-14 goes up and down according to the solar energy. So you get to compare this graph here with a graph of solar energy, right? And when you do that, you get a very strong correlation, over 80%.
Yeah.
And when you look at this graph, what they feel, you've got the red line and some of the other are colored differently, but the black line is actually the recorded temperature in the proxy, right? So you're comparing the different cycles, which are like a sine wave, and you're adding it together, and then you're comparing that with the activity of C14
Right.
in the atmosphere.
Right.
And they jibe at over 80% correlation.
Right.
So you could say that maybe the sun is affecting the temperature, or the temperature here on the earth is affecting the sun.
Right.
Right? You don't know which cause, but I think it's kind of commonsensical. And then you say, okay, if that's all
Or
the
aliens. You forgot the aliens.
oh, you and your aliens. And so when you compare the actual sum of the cycles,
Yep.
And you then look at the temperature in the proxy, and you sort of like subtract one from the other, you've got so little left that there isn't really any room for global warming.
Right.
It's already warmed.
Yep.
So why do you want to bring in greenhouse gases to explain something that doesn't exist?
Right.
Well, they're scientists, right? I've got my idea. You've got yours. And the IPCC, which is the intergovernmental panel, it's not the interscientific or international
Yes. Intergovernmental
panel
Yes.
from climate change, right? So it's controlled by politicians.
Right.
They sort of picked out a fellow by the name of Irenaeus, and he had done an experiment in 1896. And I think we've got
We got a picture.
we have a picture.
Hey Al.
I think it's this one here.
Hey Al. You have
Yep.
5 minutes.
I have 5 minutes, yes.
Yeah, 5 minutes. Okay. We'll do this then, because there's one thing I want you to hear before you take off.
Right. So
But I'll let
What-
Alan finish.
what Irenaeus discovered, right, is that when CO2, when the surface emitted radiation, and this is, it's long wave radiation up into the atmosphere, there was a capture of some of the energy, which then got beamed back out. So you grab a photon, hold on to it for a while, and then you send it back out, right? So he had the idea that half the photons being re-emitted would go up and cool the planet, but the rest would come down and heat it up. Well, the IPCC caught on to this idea, except that it wasn't big enough. And secondly, this 50-50 split was in his imagination. It was never observed, and he never had the science to actually say, we know how to calculate this.
Right. So our Irenaeus starts with an assumption that he made up in his head,
Right.
and basically got mutated into fact. That's
Right.
what you're saying. Okay.
Now, later on, you have in 1988, you have a fellow going to the Senate and spouting off Irenaeus's theory and saying, here, we can explain global warming. Right? Except that he has to change this, and the amount of radiation coming back is 67%, and the radiation going up is 37%, and those numbers are mostly imagined as well. Yeah.
And they took Irenaeus' number, didn't they?
Well, yeah, Irenaeus is,
Or
he was 50-50. So he's changed the numbers a bit to match the theory of the IPCC,
Gotcha.
right? And these numbers here fit my narrative,
Yep.
and therefore you don't need science. You just fit them to the narrative, right? So one of the next one over is by a new physicist, Yong Zong, and he has a podcast himself, and he's a physicist, and he does lots of things on spectroscopy. Right. So he sort of points this big mistake that's going on in the IPCC. Okay. So there is a theory that applies to gases being heated up, and it was done by Planck. And what he did is he set up an experiment in a black box, so there's no radiation coming in, and he sets the temperature at as close to absolute zero as possible, and he evacuates the box. So you've got a vacuum, you've got a very low temperature, and then when he puts in something that's heated, it radiates.
Right.
And you sort of record the frequency of the radiation. And you get a nice big distribution. And that leads to a number of things that are in quantum mechanics, but we won't go there.
Okay.
And what that does, though, is if you start letting in air,
yep,
this whole system breaks down, because holding the temperature, it's almost zero, and in a vacuum, you force the material to radiate because it doesn't have anything else it can do. It can't it can't conduct itself. Like you heat a rod, and the energy, the heat will go down from one end to the other, like electricity would.
Yep.
Right. And the other thing is you can convect. You let air in. Okay. So as soon as you let air in, it's no longer a black body situation.
Right.
And this whole dynamics changes.
Right.
This whole dynamics changes. Right. So the IPC, they are producing models in which this is allowed and which is not physical. So if you put in air, what happens is that the ground, when it's emitting radiation, gets, it goes up. The carbon dioxide captures it all right, captures the photon, right? But then it's got, 10,000 collisions of oxygen and nitrogen per second hitting the carbon. And typically, that means that 99.5% of the energy of the photons going up gets distributed into oxygen and nitrogen in the atmosphere. And they are not greenhouse gases. So they just heat up the atmosphere. They don't emit any photons. So when you're right close to the surface level, the CO2 being captured and then releasing the photon means that about 0.5% of this energy is going back into another carbon. And that means these numbers here are crazy.
Right.
And
so
of course, yeah. So this fellow here, he's showing, well, there's the surface.
Yep.
And we're walking on the surface, and the energy is going straight into the atmosphere. And it may be delayed a bit because your carbon's capturing a photon, but the carbon releases the photon back in about half a second.
Right.
Okay. So you go up here, and half a second later, you release it back. It hits the surface, gets released again, goes back here. Maybe carbon dioxide captures it, and then a half a second later, it lets go of it.
Right.
So it's not like it's a, you take it, then you keep it, you heat the earth up. No, this is going back and forth like a ping pong ball.
And it progressively transferred more and more to like nitrogen,
Right.
oxygen.
And because you've got so much air down here,
Yeah.
you don't have a vacuum.
Right.
The whole model is skewed to produce warming that doesn't exist.
Right.
And that's why all the models in the IPCC are not only wrong, but they're wrong in the unidirectionally wrong. They only are hotter than the measurements of the temperature by satellite.
Right.
Okay. So what really happens is, as you go higher up in the atmosphere, right, your oxygen and nitrogen will rise because they're hotter. That's convection, and that too is very powerful.
Yeah.
Here, let me illustrate.
Well, here before you go there, because Al's got to get going, and I know he wants to hear this.
Okay.
Because this actually made us laugh out loud this past week. So May 31st, Nature, Climate and Atmospheric Science. So if you'll please pardon the crude analogy, let me see if I can get it. Yes. So during the COVID pandemic, if you'll please pardon the crude analogy, it was a global warmist's wet dream. Everybody was locked in their homes. Nobody's driving their cars. Airplanes aren't flying. Truck traffic dropped drastically. Look at all the greenhouse gases that disappeared, basically, right? And so here we had a perfect opportunity for study. Okay, we've now removed all these greenhouse gases, all the smog in particular, and the thing is that it's common knowledge with volcanoes, of course. Tambora in 1815, when it erupted, the estimates are hard to pin down, but it caused global cooling. They called 1816 the year without summer. It snowed in Taiwan in the summer. And the estimates are anywhere from tens of millions to hundreds of millions of people who died as a direct or indirect result, because it caused massive famines all over the world, which led to malnutrition, which led to disease. And also, this is another thing, you probably knew this already, but I never thought about this till I was studying for this. The other thing is, if you drop the temperature, it messes with the rain cycle. So things like the typhoons and hurricanes and whatnot, all these massive dumps of rain, they don't happen. So you greatly reduce the evaporation of water from the oceans, for example. So that led to crop failure as well, right? But the thing is, the dust from Tambora, that's what caused the cooling, because it made the sky, red and dark all over.
The particle masses, it just reflected the sunlight.
Yeah, reflected the sunlight back out, cooled everything down. So global cooling, we know this for a fact, kills more people than global warming. And we're going to, well, depending on the time, we're already pretty late here. But anyway, so what happened during COVID? When everybody stayed home, I don't know about you guys. I'm a hardcore introvert. So to me, it was like, this is great. I don't have to leave the house. Nobody's going to come to my door. Hey, sign me up, But anyway, so what happened, and this is all in this paper. The references are in the description of the video. So what happened? Earth's temperature went up when they got rid of all the greenhouse gas emissions, and all this traffic stopped because all the smog dissipated, and now the sun's light came in unhindered and heated up the Earth's atmosphere. Carbon dioxide dropped only a little bit. Anyway, it was let me read you the quote here. The aerosol loading across southern Asia decreased by as much as 18%. That's a lot. That's a big chunk. And during while the CO2 during 2020 is dropped by about 1%. So mitigation strategies focusing on the phase out of fossil fuels will lead to quick removal of the short-lived aerosols, while the longer-lived major greenhouse gases decrease much more slowly, likely resulting in, get this, So let's say Greta Thunberg gets her way, and everyone stops driving fossil fuel powered cars. Okay, what's going to happen? Undesired net warming of the climate during the decades-long transition period. So, in other words, if we stopped it all today, it would still be decades of global warming. Because once you get rid of all that, you get rid of all the atmospheric, the aerosols as well, the smog and whatnot. So, anyway, this made both of us laugh out loud because I mean, here we had perfect. How can you arrange such an experiment? Okay, we're going to lock down the entire planet.
And I think it was unforeseen or unprojected by them. I don't think they thought that people would catch on to this, you know.
Yeah.
And I did read a couple of papers on it, and I laughed out loud as well, going, hey, there's your face palm.
Yeah, that's right. Anyway, I wanted to touch that before you took off.
Yeah.
On that note, and just before I leave, I did want to mention John Coleman, the founder of the Weather Network. Have you seen his video when he was on CNN?
No.
If you haven't, I'm going to encourage every listener out there to just YouTube verify this. Check out the interview with John Coleman, the founder of the Weather Network, being interviewed by a CNN guy, and I can't remember the guy's name, but he obliterates the global warming narrative. It's phenomenal. Yep, really interesting. On that note, I do have to leave you, gentlemen, and you, the listeners. I just want to say a great thank you, and I look forward to next week. And as always, God bless everyone.
Right on, man. Thanks so much for joining as long as you could.
Yep, absolutely. You take care, and Alan, you as well. It was a pleasure.
All right.
Thank you, Al. Hey, there's
Thank
an echo
you.
in here.
Take care, gentlemen.
Take care. So this is so I want to explain something about these three pictures here.
Yep.
If you've got a black body situation, vacuum, low temperature, your emissivity is 1. That means 100% of the decrease in temperature of the body will come from radiation. It's 100% radiation.
Okay.
You let in air, and this number goes down. Okay. Because the air is sucking the heat off the hot object or the surface, as well as radiation. So the radiation now becomes a fraction, right? So that means you have to start going, as you go higher up, the temperature gets colder and the air gets thinner, right?
Yes.
So you start off down at the surface, almost all the heat being lost is due to, warming up the air and having it go up into the sky, convection, right? If you go up about 250 miles, where it's quite cold and it's very much thinner, you now get into the 50-50 zone where there's 50% radiation and 50% air cooling the planet. So you have to kind of like add up all the different layers and see what the net effect is. And what the net effect is you make this number here 0.6. So what happens when you take your physics theory, and in this particular case, you're talking about the Stephen Boltzmann constant, and the intensity of the radiation is a constant times this number, and times T to the fourth, temperature to the fourth power. And you can then solve the equation. When you know the intensity, you can solve for the temperature, right? So the temperature here is calculated by the IPCC as being 33 degrees colder, where we would be substantially.
Yeah.
So they're using an emissivity of 1, and and with the greenhouse effect causes the temperature to rise 33 degrees Kelvin. So we have a 288 Kelvin surface, which is the right answer, right? Well, no. Actually, when you put in the correct emissivity, the average emissivity is 0.6. And then when you apply the formula to get the temperature, you end up with 288, which is the correct answer, which means the greenhouse effect is 0. Because what happens that isn't in here is all the heat that's taken out by air through conduction and convection that isn't taken into account because E equals 1. And therefore, it's 100% radiation.
Right.
And of course, the conduction and the emissivity are more powerful. And you can see this. I've got a picture, a chart here, if we can find it, which someone has done an experiment and actually calculated. Yeah, okay. You see? Okay, he's measuring pressure in torr, right?
Yeah.
Okay. Think of it as 14 pounds per square inch as the weight of the atmosphere at ground level, right? So that's very high pressure. So conduction and convention contribution 99.6, and at 110,000 feet, it's still 99.3, right? And it's only when you get to 250,000 feet that the conduction drops down to 50%, and it's equal to the radiation. Well, that's way up beyond the stratosphere. So everything below the stratosphere, the emission of the long wave radiation makes a very poor contribution. And that's what the greenhouse gases effects is supposed to be. It's supposed to be 95. Here's the last line here, 95.5% greenhouse fraction, and the air is only 0.5. And this work was done by Tom Shula and published this year.
So let me just to back up, because the way you said that will go over most people's heads.
Okay.
So basically, the greenhouse effect model is saying that they're claiming it would have had retained 95.5% of the heat, basically.
Well, you're looking at how to cool the planet, right? You have to take the sunlight and you have to cool it by the temperature rise that the sun has heated it up by. So you want the air and the radiation to get it to leave. Mm-hmm. Well, if you're only contributing 0.4% of the energy leaving the planet, that's not much cooling.
Right.
But if you have the gas, you can't have gas and a vacuum at the same time. And the gas is more effective at cooling. So the cooling goes up.
Right. So right. Okay. So you're saying the greenhouse model predicts a 4.5% cooling. Even worse. What this fellow has done is kind of stratified it. At ground level, 110,000 feet, and 250,000. That's neat.
So as you go up in the atmosphere, the radiation that's leaving and cooling the planet increases, right? Well, with the greenhouse effect, it's supposed to be boxed in. It's supposed to be kept.
Right.
And therefore, it doesn't get radiated out. And so it heats up the planet, and it's supposed to heat up the planet 33 degrees.
Right. Which is
well, when you look at those numbers and you see, okay, I'm a mathematician. I'm used to adding up all those numbers and dividing them in my head, because there's only like 4 numbers and they're extreme.
Right.
Right. So you can tell immediately that that's not the greenhouse effect.
Right.
So when you put that information into the last picture, what you're saying is there's heating, there's heat loss going up.
Whoops.
Yeah.
Wait,
Can you
or
go
maybe
back
that
one?
was the one.
Yeah. So when there's the heat loss, it starts with an emissivity of 0.6, and then that goes up, and then you get the atmosphere itself, which is heated by the sun's rays coming in, and between those two exiting through a dense gas, you can cool the planet in a way that this IPCC doesn't record. It doesn't function on that logic. See, what it's saying is, oh, there's a vacuum between here and here. Right. And here's the temperature it would be without the greenhouse gases. And here's the temperature with greenhouse gases. Well, it's nonsense. It's absolute nonsense. This 33-degree difference here doesn't exist. Because when you use your 0.6 emissivity, you end up with this.
Right.
It's like, I guess one way of illustrating is to say, okay, you've gone into the store, you've left your dog in the car, and it's a hot day. Mm-hmm. Suddenly you realize, oh, it's going to get hot for the dog, and you run back. Mm-hmm. So the sunlight's coming in, and it's bringing in more radiation than is going out through the windows. Because the radiation is leaking out the car slowly. Right. Because it's not fast. Because it keeps on stopping and capturing a photon. Right? And sending it back down again. But that slows the whole process down. So what do? You open the car windows. And what happens is the hot air and the cold air outside the car start to mix and the temperature goes down. And then you say, oh, it's still too hot. So what do? You get in the car, you drive around the parking lot with the windows down, and you force air through, and that's convection. So the fastest way to get your dog back to room temperature is, conduction and convection. And it works.
Right.
So this is the conduction and convection model, in which you start with the temperature of 288 down here. And of course, when the temperatures are the same, there's a sort of a dynamic warming keeping it constant, but there's no energy transfer because they're the same temperature.
Right.
So if the temperature is the same, you don't get any radiation.
Right. And no transfer.
Right. Well, no, you'll get transfer and convection, but you won't get radiation.
Right.
So, and actually, if the atmosphere were all the way up to the top that way, you'd have virtually no radiation, and it would be all transmission and convection. Right. So what this says is, if there's no 33 degrees, there's no greenhouse effect. And you can also apply another law. There's a law called the ideal gas law.
Yep.
And what that's PV equals nRT, pressure times volume equals the number of moles times R, a constant, times T, the temperature. Right? Well, if you apply that to the Earth's temperature, you get a temperature value of 288. This one, the ground level temperature is 288. So that confirms that this is wrong. So they're working from a model that includes a false assumption, and I can't imagine that they don't know it.
Right.
But
has to wonder.
Having spent $100 billion on the research.
Yep.
Yeah, but it's all those cycles that were discovered in the 19th and early 20th century. They only put one of those in the IPC model, and they only have one astronomer who was set on finding those cycles and measuring them.
Right.
Well, the Schwab cycle, which is what was measured, it only has like 0.05 watts per square meter. That's chicken feed, right? You're looking for 3.5 watts extra forcing. And it's not in the Schwab, but it is in the other ones if you add them all up. So they're deliberately not putting numbers into the model that would explain the heating unless it's CO2.
Right.
So they're telling you everything you need to know, except they're leaving part of it out. You know, and then they call that science. No, it's not science. And the thing is, the science, the people who do some of the science, they're being told to look at this problem and this problem and this problem, but they're leaving out the astronomical problem.
Right.
So the scientists themselves are doing papers that are telling the truth about what they've discovered. They just haven't given you the information from the rest of the story that would destroy the IPCC's narrative.
Right.
And it's absolutely irresponsible.
It's anti-science.
Well, worse than that, it's an agenda.
Right. Anti-science.
Well, what's the agenda?
Right.
Well, look, you scumbags, you ought to be worms.
Right.
Look what you're doing to the planet.
Mm-hmm.
You should stop worshiping your God and you should start worshiping the planet. Yep. It's much more important than God is.
It's worshiping the creation rather than the creator.
Exactly.
Yep.
Right. And why do you want to do that? You're going to keep everybody in fear and anxiety, and they're going to get depressed. And when you get everybody in that state, what happens to them? They wander around uselessly as they did in the Soviet Union, lying to all the masters, telling them exactly what they're supposed to tell them when they know it's not true. And they walk around in basically permanent depression.
Right.
Because that's better than being shipped off to the Gulag Archipelago and dying in 6 months.
Granted. Yep.
Except eventually you get so fed up with lying to people who want this falsehood, and you just give up and throw up, and you tell them what you think of them, and you tell them the truth, and you get sent to the Gulag Archipelago, and you're happy because they don't care what you say anymore. And you get a bunch of people who actually talk to each other and find out about each other, and who they will actually pull together and work even in the Gulag Archipelago, because that's part of the value system they grew up with, is earning your living.
Right.
And they kill these people because we demand that you obey us by telling us and telling everybody else what you're told to tell them. This is a terrible agenda. It is anti-religious, it's anti-psychological, it's anti-human. And, we already have a machine that turns people into worms. We don't need the IPCC.
Right. And on that note, this is a point you brought up, and I don't know if you had seen this, but you brought this up to me a couple years ago.
Yeah.
But I don't know if you'd seen this. Now, this is going to be a little hard to see from where you are, because it's only on the big computer.
Mm-hmm.
But this is a glacier in Iceland.
Yeah. Okay.
And they commemorated this plaque. So there it is in Icelandic, and they translated it into English. OK is the first Icelandic glacier to lose its status as a glacier. Mm-hmm. In the next 200 years, all our glaciers are expected to follow the same path. This monument is to acknowledge that we know what is happening and what needs to be done. What has happened, only you know if we did it. August 20, 2019, 415 parts per million CO2. So of course, as we know, so this is from Kleinberg and Ord's their part 4 paper. It was actually, I think, 7 parts in the series on the little ice age that they did. But this particular graph, a chart here, you can look it up. By the way, all the references for these are in the description of the video down below. And this is open access now. CRS has made it all open access. What you're looking at here, these are glaciers in Iceland, Switzerland, Norway, Greenland, and France that overran farms or entire communities. In particular, the first one, Great America Euroco. I almost said it. I learned how to say it yesterday. I worked really hard. Great America Yoku. That particular glacier was named after
Breda.
after the farm that it overran. So these were multiple farms. This used to be a cereal, primarily cereal is what they were growing, cereal grains. And this glacier grew 9 kilometers and wiped out entire towns and farms. Mm-hmm. And now it's melting back, and they named the glacier after the farm that it destroyed. So now this is only one example. You can see it took out farms or entire farms or settlements for them. It was 9 kilometers of like you were saying, from Chalk River to Deep River is only 5. So now a glacier has grown over Chalk River right through to Deep River and buried it under ice. You can no longer farm there, obviously.
So let's put this in some better historical context. Mm-hmm. Around the year 900 and something, Iceland started to get new inhabitants, mostly Norwegian, the Vikings. Right, this is the age of the Vikings. The Vikings and maybe some monks from Ireland discovered Iceland. It had no native people. Right. Okay, but the temperature was warm enough to grow crops. Okay, but I believe they discovered it sometime deep into the season, and so it was covered with ice when they first got there. Then they moved west a bit, and they established a colony on the tip of Greenland, which apparently they did in the summer because it was green.
Right.
And they started to raise cattle and farm on the southern tip of Greenland. Then they got even more adventurous, and they went way west, and they ended up hitting Labrador.
Okay.
And Labrador was Hell, which means flat, right? In Icelandic, it means flat.
Right.
So they followed that down south, and then they came to the tree line. And so that was tree land, right? They went farther down and they hit Newfoundland, and there they got off because they discovered there were grapes growing in Newfoundland.
Right.
But we found out where they stopped. We've now got artifacts from there, and it's 10th century.
I've been there.
Yes, 10th century artifacts from the Viking era. But it's too cold to grow grapes.
Right.
Not So if it's too cold to grow grapes now, was it warmer or colder when Eric, not Eric the Red, it's his son.
Right. I've forgotten the name, but yeah.
Yeah. At any rate, in 1000, Eric the Viking was eating grapes in Newfoundland because it was warm enough to grow grapes. Mm-hmm. And now you can't. So it must have been warmer, right? And that's what the it says on our graphs with the cycles.
Right.
That around 1000 AD, 1100 AD, it was warm enough even to grow barley.
Yep.
And not only that, but if you went up north, you would find a forest, which around 1500 AD, according to carbon-14 dating, burned to the ground. And it never revived because it had become colder, right? So how much colder was it? Well, in kilometers, the tree line now is 100 kilometers south of that extinct forest. So that means that extinct
And where-
forest
where's
couldn't
that?
grow there today.
And where's that one? That's in Labrador?
Well, is actually in Quebec, up near Ungava
Oh,
Bay.
Yeah, right. Way up north of Quebec. Gotcha.
Yeah.
Okay.
So that forest could grow, back in 1,000, 1,100, and it could survive up until 1,500. When it caught fire, it never survived.
Right.
And since then, the forest line, the tree line, has moved down 100 kilometers south. Well, that means that back then, 1,000 to 1,500, the temperature was warmer, right?
Yep.
In complete contradiction to the hockey stick.
Yep. And these, for those watching, these glaciers, many of these Icelandic ones are now melting back. The Breda Mercurial has actually melted back now, where it's exposed these farms that it overran.
Yeah,
And,
but first it came down and now it's going back up.
yes.
So that's a cycle.
Yep.
And so often when you see these pictures or images or lines showing, how big the ice in the Arctic is and how close it gets to melting in the summer, etc. A lot of those, they'll chop off the data so that it's only 20 years or so. If you go back, 1,000 years, these things go up and down, up and down, up and down, and then they show you the last 20 years and it's all down. And you think it's linear and going down. That's an optical illusion. If you add in all the data, you'll see that it's cyclical. It's not linear.
Right.
So again, they hide part of the data from you so that they can fit the narrative.
Well, and the point you made to me a couple years ago, which was this very significant point with those glaciers, was okay, they grew and overran the farms, and now it's warming up again, they're melting back.
Yeah.
So is it going back to what is normal, or is it global warming? So, and of course, I always bring up the Ice Age, which is significant for this Axel Heiberg Island, which you're familiar with Axel Heiberg, right?
Yeah.
So those of you who are not familiar with it, Axel Heiberg Island,
It's
is
way north.
way north. So I mean, it's way up there. So talk about tree line. This is way above the tree line. But the reason that island is famous is because it has what the evolutionary scientists call polystrate in situ fossil forest. Now here's the catch. I don't know how much of this you know or don't know, so I'm just going to ramble. But so these trees, I disagree. I don't think they're in situ, but I'm going to go by their rules. I'm going to go by what they claim. Now, Bassinger, the guy, the one of the lead researchers, I'd written to him years ago trying to get some samples of this because these trees are not fossilized. You can cut them with a handsaw. You can burn them. You can drill core them. All kinds of stuff. The Eskimos would build campfires with them. I mean, it's wood. It's not even fossilized. They claimed it was 45 million years old. I wrote to this Dr. Bassinger guy trying to get pieces for research and for my own museum. And so it's like he was real quick. These humanists are worse than vegans for telling you they're humanists.
My friend Ian Taylor, I think you know Ian Taylor.
Yep. Yeah. I was getting to him.
Yeah. He managed to get through to one of the scientists about this piece of wood. And they carbon dated this at 40,000 years.
Yep. But there's more
so
to that story.
So the wood is 40,000 years old, and the strata is dated by evolutionary dating as, what did you say, 45 million?
45 million, yeah.
Yeah. So carbon-14 and evolution are out by 1,000.
Yeah.
1,000
Is that what it is?
error. One
of
the
factor of 1,000?
Yeah.
Because my math skills are horrible, just so you know.
Okay. You're forgiven.
Okay, thank you. Well, so I wrote Bassinger, and it's like he writes back. He's like, "Oh, it didn't take me long to find you. You know, I'm some conniving, deceitful creationist, and trying to covertly get some some of the wood samples from it, right? You know, humanists like me, you know, we look
We
down
eat
on
you for breakfast.
Oh yeah. So I wrote back. I'm like, you didn't take long to find me. Well, did you use a search engine? Ian Juby at ianjuby.org. What part of this is me hiding, right? So anyway, so long story short, he refused to give me any pieces of wood, right? Even though he's taken some of this home and building lamps out of it.
I know he was exercising his white privilege.
I guess. So so I'm praying about it. I'm like, all right, Lord, you heard the guy. You know, could you get me some pieces of wood, Axel hybrid wood? I'd really like some for my museum and conduct research and whatnot. And I think it was a month later, without asking, I was holding legally obtained pieces of Axel hybrid wood, which are still in my museum today. There's a piece right there, one of the pieces. God provides, and it's true. I handed this out to people, and I encourage them when I'm handing it out at my talks that, you know, run your fingernail into it. It's wood. It's not fossilized. And so I sent a piece to Vance Nelson. So he sends me back a video of him burning it. Dude, what are you doing? So, but I got my revenge because he sent me.
You know, but you know, if it's actually in situ, if it was actually growing there,
yes,
you have a tropical tree growing in the
Bingo.
high Arctic.
Bingo.
In the last 40,000 years.
Bingo. And you said that keyword, tropic.
So the more you say that, the more ridiculous you sound.
Yeah, well, let's take a look at this. So I'm going to show you what Bassinger and team wrote. So what we're looking at here is tree rings, of course, and so you have what they call the early wood, this light part, which happens in the spring. It's a fast-growing, soft wood, and then in preparation for winter, as it's shedding its leaves, etc., it grows a slower-growing, thicker, much harder outer portion of the ring called the late wood. So you have the early wood and then the late wood, and then it shuts down for the winter. Then the next season, early wood, late wood shuts down for the winter, etc. Mm-hmm. So now this is some BC redwood, and you're looking at this under a microscope. So these are tree rings here, and you can see the early wood and the late wood. You can see the density, increased density of the cells, and the softer wood here. This is a piece of Axel hybrid wood. I don't even see a tree ring there. Do you see a tree ring? It's pretty hard to see. It's marked with the A and the B. So in one season, first of all, notice there is no late wood. So way up, almost at the North Pole, way above the tree line, these Axel hybrid trees, according to the evolutionists, are growing 4 times the growth rate of modern temperate forests in BC. And they're doing it without any late wood. They didn't experience winter. So literally, there's that word you used, tropical. That is what we are looking at here.
Mm-hmm. And I would say that would support the idea that the Earth's axis was 90 degrees.
Okay.
Because then you get sunlight sunlight shining on the North Pole 24 hours a day.
Right.
In which case, there isn't any room for winter because you've got solar radiation coming in the whole year long. Now you can start creating winter by, getting maybe 3 or 4 degrees off the center, right? And then you get a portion which will go into winter, etc. But obviously at 23 or 23 and a half degrees, you get a whole lot of winter in Canada now. Right. And you get a whole lot of
So we got to pray for global warming is what you're saying.
Yes, that's exactly right. We need more prayer meetings to pray for global
warming. That's right. Okay.
Yes.
So, there's the tree rings. So the reason Vance burnt the wood was because of this absolutely fantastic paper, which again, the reference is in the description of the video. Nelson and Thomas, they put together this fantastic paper that I find myself repeatedly referencing, where they used carbon-14 dating. Now, of course, carbon-14 is one of the most, whoops, I'm sorry, I'm looking at the wrong screen. I had it on you the whole time. Oh well. And we cannot see your screen. Yeah, thank you. I'm going to back up. I'm going to re-show that. Thanks, Moose. I apologize. I just realized I was looking at the wrong screen. Whoops, there it is. Okay, so up top is the Axel Heiberg wood. The tree ring is marked A and B. You can see no late wood. It's only early wood. And here is the BC fir wood. And you can see the late wood and the early wood. And you can see that in one season, the Axel Heiberg tree, experiencing clearly tropical conditions, had 4 times the growth rate of a modern BC temperate climate. BC fir. Pretty amazing. So, of course, the question comes, because remember, the evolutionists are saying these trees grew there, not me. I disagree with them on that. I think they floated there during a worldwide flood, but I'm going to go with their rules for now. They want to say it grew there. All right. You've got clear evidence of tropical conditions almost at the North Pole here. We're talking. Okay, so the reason Vance burnt the piece of the wood sample, or a piece of the wood sample I sent him, was because of this paper where they were doing carbon-14 dating on wood and basically fossil samples similar to that throughout the entire fossil record. And here it is down, you can see it, 1, 2, 3, 4, 5, 5th from the bottom, and you can see they got a radiocarbon date of 39,720 years, plus or minus 270 years for those wood samples. I was the one that provided them that sample from my museum, actually. And you mentioned Ian Taylor. So when I was writing Bassinger, I didn't know Ian at the time. It was years later I found out about this. It was right around that time Bassinger and team had sent samples to a radiocarbon lab to check for carbon-14, see if there was any there. They're expecting, and they told the labs, I have no doubt, they told the labs we're expecting, it to be about 45 million years old. So here we go again with God's provision. Ian Taylor happened to call, he told me about the story later on, years later. He happened to call the carbon-14 lab, and if I recall, he was trying to figure out, okay, if I can get a sample of Axel Heiberg wood, what do I need to do to get a carbon-14 tested? And
you have to have lots of money.
Well, it's not that. At that time, it probably was pretty expensive. It was a long time ago, and there was only so many labs that did it. And he was talking to the technician, happened to catch him just as he was finishing up the paperwork on samples that the Bassinger team had sent for carbon-14 dating. And as you said, I think I remember 45 or 50,000 years old is what they got. And so the technician. Oh,
that's very close to this number here.
Yeah. So that's why I bring that up. But here we go again with God's provision, right? It's like, what are the odds that he's going to call the technician who's literally filling out the paperwork, and the topic of Axel Heiberg wood comes up? He's like, I just happen to have ran a date on it, and it's obviously contaminated because we've got an age of 50,000 years or whatever it was, right? So anyway,
you can do this with coal as well.
Yes. Yep.
So you can take all those evolutionary dates over there, and then you can do carbon-14 dates on coal samples that come from those strata, and you will get 50,000 years or less.
Oh, and I made a mistake. So Vance and Brian have 55 million years.
Oh,
For
okay.
axial hybrid. So that'll be the
I
correct
don't
number.
think that makes much difference.
No, it doesn't. It's still a factor of 1,000. You said
Yeah, well, it's a
1,100 now.
yeah, it's a little less than 1,000. Oh, yeah, a little bit more than 1,000, right?
Okay.
So yeah.
Okay. Well, and one more thing I wanted to bring up before we. Okay. So with you mentioned, how you can go through carbon-14 dates with the entire fossil record. Well, up in the top left-hand corner, see those pink squares? Those are carbon-14 dates on Neanderthal man fossils.
Mhm.
And these green ones over here, notice that the axial hybrid wood dated older than these, even though the evolutionists would say they're way younger because these are dinosaur bones and carbon-14 dates from dinosaur bones. Notice also human fossils dated older by carbon-14 dating than the dinosaurs did.
Mhm.
Anyway, that's not what I was.
Yeah. Well,
Sorry.
I spotted a number. If you go back one.
Yep.
This number is the highest number on the wood one, on the wood dating.
Right.
And that was equated to what, 55 million to 200 and some odd million. The bottom line down here, it was over 200 million years in date, evolution wise.
Yep.
And here's the Neanderthal man,
Yep.
and he's got the same carbon date.
And it doesn't matter where you get the samples from in the fossil record, it always comes back between 5,000 and 55,000 years old.
Mm-hmm.
Always. Every single sample I've heard, including things like diamonds, coal, crude oil, fossil wood, which I've collected some, coal, as you mentioned, I've collected some, provided samples for various researchers. They all come back between 5 and 55,000 years old, carbon-14.
Mm-hmm.
Another interesting point coming back to global warming. So this is a map. Here's the North Pole. And I marked the latitude lines from the Greenland ice cores, the grip and end grip, just to give you an idea of where they are. The green stars are all mammoths. And where they're found, you can see they're even further north than the Greenland ice cores. Well, it's not just mammoths you find there. In fact, I wrote down the list because it's such a long list, I always forget. Where did it go? I lost my list. Give me a second. Here it is. So, up here in primarily Siberia, but also, Greenland, the Canadian high Arctic, Nunavut, Alaska, the Yukon, all these way above the tree lines, we find not just frozen in the ice and mud. We find woolly mammoths, which are not a winter creature. They would not fare well at all. You don't just find mammoths. What you also find is horses, camels, rhinoceros, lion, leopard, bear, tiger, reindeer, giant beaver, the musk sheep, musk ox, donkey, bison, wolf, woolly rhinoceros, moose, saiga antelope, sloths, hyenas, and even walruses, all buried, frozen in the ice and muck. So Mike Ward, when he was researching all this, mostly for the mammoths and mastodons, is what he was researching in the frozen poles. He was trying to find a comparison. It is such a broad biodiversity. So get this, the only equivalent biodiversity that we can find in modern day times that compares to Siberia and all the extreme high Arctic is the African Serengeti. That is the only place on Earth that has biodiversity so wide-ranging to match that of northern Siberia, where right now it's averaging, minus 20 to minus 50 Celsius, right? So hardly tropical, hardly like the African Serengeti. So it's all frozen now. So if we warm up, and we get global warming, we really need to pray for this, because what will happen is we'll turn this, instead of turning the planet into a wasteland and killing all life and ecosystems, we're going to gain back all that we lost. What has changed here? The Earth has gone drastically colder, and even if it is warming up now, that's a good thing. It's not a bad thing.
To get arguments on the line of
Okay, so we got to call it a quits here because it's already 8:30, and you still got to drive home. And I only wanted to go an hour and a half anyway. Okay. Thanks, folks, for the ones who did tune in. And yes, thank you for Moose. Thanks, Moose, for pointing out that I didn't have it on the screen. I wish I noticed that sooner. I would have fixed the problem. I guess that's about it. Did you have anything in closing you wanted to say?
Well, do you have this map?
No. What is that?
Well, this map here are the temperatures recorded in papers that were focused on the temperature of the Earth 1,000 years ago.
Okay.
Right?
Did you send that clip to me?
Mm-hmm.
One
Yeah.
second. Let me see if I can call it up. Marcus Ott, or it must be Marcus Ott.
No. It's actually from 30,000 scientists disagree. 1,000 Frawley, PhD. That's what it will.
Okay, 1 second. Hold on there, folks. I'm going to see if I can find this video. 1,000 scientists.
Yeah, it's 31,000.
Oh, 31,000?
Yeah.
Okay. 31,000.
Well, that's the paper.
Scientists agree. What's the title of the video?
Yeah. This it's taken from this one here. Okay, but I did send it to you. But anyway, rather than waste the time looking, it has about 30 papers with temperatures higher 1,000 years ago than today, and it has 2 papers which have lower temperatures.
Okay.
Right? So this goes against the hockey stick.
Yeah, directly against it.
Right? And it's not just one paper, it's like over 30 papers.
Right.
Right? So again, just like the Vikings in Iceland and Greenland, and eventually Newfoundland, things were warmer. And they were not only warmer on this side of the Atlantic, they were warmer the other side. They were growing grapes to make wine in Scotland.
Right.
So this is all the way across the ocean. That's just all this area was warmer. And apparently it stayed warmer for 200 years. But no. They sort of cut that area out and say, well, that was a special area that was warmer temporarily, just over a small area. It wasn't over the entire world.
Right.
Yeah. And well, all these measurements here are all over the world. So that destroys that counter argument.
Right.
They just can't admit that maybe that science is different than they publicize, because then, well, they wouldn't get it. Then we wouldn't be scared.
Right.
And then we might recover and stop committing suicide. And how dare you not commit suicide?
Yep.
And then, all the one world government would disappear because it's not a good idea.
Right. We know where they're going. Alrighty. Well, we're going to close it up for the night. Thanks, everyone, for those who were watching and joined us. I forget how many. I didn't look, actually, to see how many were joining. But anyway, thanks for joining us. God bless you all. Next week, I have not yet heard from Bill Gibbons. I did write to him and ask him if he would come on the podcast and bring his his cast of not a fossil, his cast that he made in the Congos of Africa of this Mokele Mbembe creature, whatever that is, which sure looks and sounds like an awful lot like a dinosaur, still alive today. And he apparently got casts of one of the footprints from this creature. So I'm still trying to get him on. If he can get on next Friday, I will have him on. If not, I will probably do chemtrails, because that is a topic that everyone's been requesting, and is a topic that came up again a whole bunch the past couple of weeks. So we'll discuss that as well. Anyway, I will say all that for now, and thank you all for joining us. God bless you. We'll see you.